Welcome to The Explainer. In the next 5 minutes, we're going to get you up and running with one of the most essential tools for data in Python, the Pandas library.
You know that feeling, right? When you're just drowning in data, trying to wrestle with some totally chaotic spreadsheet or a messy text file. Raw data is often inconsistent and, let's be honest, just a real pain to handle.
But what if you had a tool that could just tame all that chaos? Well, that's Pandas. It's less of a library and really more of a data superpower that puts you firmly back in control. So what even is Pandas? It's a library for Python, yeah? But it was built for one specific thing: data manipulation and analysis. Its entire reason for being is to bring structure and order to all that raw data.
The best way to think about it is like a spreadsheet, Excel or Google Sheets, but on steroids. Now imagine that super spreadsheet lives right inside your code so you can automate it and analyze it on command. In a nutshell, that's what Pandas is.
To really use this superpower, you've got to understand its core building block. And in the world of Pandas, that is the data frame. Absolutely everything starts right here. The data frame is the real workhorse. I know the official definition sounds a bit technical, a two-dimensional labeled data structure, but really it just means a table, with rows and columns. And what's so incredibly useful is that each column can hold a different type of data: text, numbers, dates, whatever you need.
And boom, here's what one actually looks like. With just a couple of lines of Python code, you can turn some raw data into this beautiful, powerful data frame. See the dates there on the left? That's the index. It gives a unique name to every single row. And across the top, we've got our column labels: A, B, C, and D. Just like that, our data is organized and ready to be analyzed.
Okay, so once your data is loaded up into a data frame, the very first thing you're probably going to want to do is just take a peek inside to see what you're working with. The absolute fastest way to do that is with the head method. You just add .head to your data frame's name, and boom, Pandas shows you the first 5 rows. It's the perfect way to get a quick feel for your data's structure. But if you want to get even more insight, you use .describe. This single command gives you this incredibly powerful statistical summary of all your numerical columns. Instantly, you can see the count, the average, the standard deviation, the min and max values. It's just a crazy efficient way to spot trends or maybe even errors in your data. Now, viewing data is useful, for sure, but the real power of Pandas, that comes from selecting the exact pieces of data you need. This is how you start to answer specific questions. The single most important thing to get about selection is this key difference. You can select data by its label, like a date or a column name, or you can grab it by its position, like the first row or the third column. Pandas has a specific tool for each of these jobs. So when you want to select by a label, you use .lock, LC. Just think lock for location. It's all about using the actual names of your rows and columns, which makes your code super clear and easy to read. Let's see it in action. Right here, we're telling Pandas, hey, give me all the rows from the label 2013-01-02, all the way through 2013-01-04, and I only want columns A and B. Now, here's the key thing to remember about .lock. When you slice like this, the endpoint is included. See that? The row for the fourth is right there in our result. But what if you don't care about the labels? What if you just want to select by its number, its position? For that, you use .iloc square bracket. The I stands for integer. This works just like the Python slicing you already know, where you start counting from 0. And here's how that's different from .lock. This code is asking for rows at positions 3 and 4 and columns at positions 0 and 1. Now notice the critical difference. With iloc, the slice 3-5 stops before position 5. The endpoint is excluded, just like it is in standard Python. It's a subtle but really important distinction. And hey, don't just take my word for it. The creators of Pandas themselves say it best. The official docs say, for production code, stick to the optimized methods, .lock and .iloc. Using them just avoids any confusion and makes what you're trying to do crystal clear. Okay, selecting data is one thing, but how do we get to those big aha moments?
Well, the answer is usually in grouping your data to find patterns. And this is where Pandas really starts to shine. The strategy is called split, apply, combine. It sounds fancy, but it's simple. First, you split your data into groups based on, say, the unique values in a column. Then you apply a function, like sum or mean, to each of those smaller groups. And finally, Pandas combines the results all back together into a brand new, tidy summary data frame.
Let's look at an example. So here's a data frame with a column A that has these repeating text values, foo and bar. Right now, it's just a flat table. But what if we want to ask a question, like, what are the total values for all the foo rows compared to all the bar rows? With just one line of code, df.groupbya.sum, we get this. It's an incredibly powerful result. See, behind the scenes, Pandas just split the data into foo and bar groups, applied the sum function to each one, and then combined the results into this new summary table. And that is the aha moment, going from a messy table to a clear insight in one single step.
So let's bring it all home. You've just seen how to take messy, raw data and completely transform it into structured, actionable insight. It's all about turning that chaos into clarity. Just think about what this means. In just a few minutes, you've really grasped the core ideas you need to command your data. You can organize it with DataFrames, you can select exactly what you need with .lock and .ilock, and you can uncover those hidden patterns with groupby. You now have a genuine data superpower right at your fingertips. So the only real question left is, what are you going to do with it? What questions will you answer, and what problems are you going to solve? Thanks for watching.